Hi everyone, today we would like to talk about refraction of wave and refraction of light. I'm Kaiqi.
I'm Joey.
I'm Yuan Xin.
So, now let's get started. The first is refraction of wave. What is refraction of wave? Refraction of wave is a phenomenon that occurs when there is a change of direction in the propagation of wave traveling from one medium to another due to a change of speed. The refraction of water wave occurs when water wave travel from one area to another area of different depth. Hence, the different depth of water is equivalent to a different medium.
Now, I would like to talk about the characteristic of refractions of wave. The first is the directions. The direction of the propagations of wave change after refractions. The second is the angle of directions. When wave propagates from a less dense medium to a denser medium, the angle of refractions is less than the angle of incidence. The third is the wavelength. The wavelength of the reflected wave in the denser medium is shorter, as the gauge of water shallower depth is equivalent to denser medium. The fourth is the frequency. The frequency of the wave remains unchanged. And the last is the speed. The speed of the wave in the denser medium is less than that in the less dense medium.
This is natural phenomena caused by the refraction of waves. The first is cape and bay. This occurrence is due to the refraction of the wave as the sea becomes shallower near to the beach. From the figure, we can see that the energy of the wave is focused at the cape. The sea near the cape is choppy and more dangerous for the swimming compared to the bay.
And the next one is thunder. Sound waves move gangster in warm air than they do in cool air. During cold weather, the air temperature increases with height. Sound waves moving outward the reflected back toward the earth due their faster motion in the warmer air. A listener hears not only the direct sound of thunder but also the reflected one. This additional sound effectively amplifies the thunder and making it sound louder.
And the third is the reflections of sound wave during the day and during the night. The speed of the sound wave is higher when temperature of the air is higher. During the day, the sound is reflected away from the earth, but during the night, the waves are reflected towards the earth. The sounds from the trumpet is heard louder at night.
Now I would like to talk about the refraction of light. This is the phenomenon of the refraction of light. The light bends when it passes through a glass block. Refraction of light occurs due to the change in speed of light when traveling through mediums of different optical density.
Then I would like to talk about some details of refraction of light. When light rays travel from air into the glass block, its speed is reduced by glass particles. The change in the speed of light in glass causes the rays of light to change direction. Then a medium that can reduce the speed of light is said to have higher optical density. Optical density is a measurement of the ability of an optical material to absorb light through it. And then, when light rays travel through different mediums of optical density, the change in light speed causes refraction of light.
These are the refractions of light. The normal is a line perpendicular to the boundary of two different mediums at points of incidence. And the incident rays is a ray of light leading to a medium point. The angle of incidence is the angle between the incident rays and the normal line. The reflected ray is light rays that is reflected as it enters a different medium. And the last is the angle of refractions. as is the angle between the reflected ray and the normal line.
The refraction of light. When light travels from low optical density medium, which is air, to a high optical density medium, glass block, light rays bend towards the normal. The velocity of light decreases, which light travels from less dense medium to denser medium. The angle of refraction is smaller than the angle of incidence. The second one is when light travels from high optical density medium, glass block, to low optical density medium, air, light rays bend away the normal. The velocity of light increases, which light travels from denser medium to less dense medium. The angle of refraction is bigger than the angle of incidence.
Now I would like to talk about the refractive index, N. It is the degrees to which light bends when traveling from vacuum to a medium. The formula for refractive index N is speed of light in vacuum divided by speed of light in medium, which is C over V. The C is equals to 3.0 times 10 to the power of 8 meter per second. There are some medium of refractive index. The first is vacuum and air. The refractive index is 1.0. And the second one is olive oil, which is 1.46. And the third is perspex, 1.50. The next one is glass crown, 1.52. And then it is glass flint, 1.66. And the last one is diamond, 2.42.
Now, I would like to talk the Snell's law. The diagram shows the light rays traveling from the water into three different mediums. N1 sine theta is equals to N2 sine theta for the three different mediums. The incident rays, reflected rays, and normal meet at one point and are in the same plate. Snell's law. N1 sine theta 1 is equals to N2 sine theta 2. N2 over N1 is equals to sine theta 1 over sine theta 2. N1 is reflective index of medium 1. N2 is reflective index of medium 2. And theta 1 is angle of incident in medium 1, and the last theta 2 is angle of reflections in medium 2.
This diagram shows the law of refraction of light. Medium 1 is air, which is N1 equals to 1, and the medium 2, N2 equals to N. N is sin I over sin R. I is the angle of incidence in air, and R is the angle of refraction in medium 2.
And the next one is about the real depth and apparent depth. Real depth is the actual depth of an object beneath the surface, and the apparent depth is the distance from the surface of the water to the elevated point. Figure 6.9 shows the effect of refraction of light. When light rays from fish travel from water to air, light is reflected away from normal. This effect causes the image of the fish to be closer to water surface.
This is the application of refractions of light. First is a lens uses reflections to form an image of an object for various purposes such as magnifications. And the second is the spectacles worn by people with defective visions use the principle of reflections. And the last is the reflections is used in people's of house doors, cameras, movies, projectors, and telescopes.
That's all for us. Thank you.